Welcome to Algebra Heaven, okay? We're going to be doing a lot of algebra this week, so strap yourselves in and don't hesitate to ask if you have questions. We're going to start with some exponents. So let's get some terminology out of the way so we know that we're all talking about the same stuff. So if we have a positive number and n is any real number, then we have this, a to the nth power is how we say it. A is called the base of the exponential, and n is called the exponent of the exponential. Okay, so this is what we're going to be dealing with in the first half of this week. And then when we say simplify, just to be clear on what that means your exponents are positive. We'll talk about why that's important later. Each base occurs only once, so put things together. No more parentheses. That'll be something that we're dealing with. And no powers to powers. So these things will make more sense once we start getting into the grit of it. I'm mixing phrases. So let's start with an example. So we're going to do example 6.1 by expanding this first. 5 cubed times 5 to the 4th. We're going to leave our answer in base 5 and look at what happens. So let's go over to our paper. Again, you can print these out, but I'm going to be doing them on my notes today. So if you do 6.1, example 6.1, we got 5 cubed times 5 to the 4th. Remember what it means for something to be cubed, right? That's 5 times 5 times 5. That's exactly what 5 cubed means. And so 5 to the 4th, similarly, right, means 1, 2, 3, 4. So now we have 5 cubed is 3 5s multiplied by each other, times 5 to the 4th, which is 4 5s multiplied by each other. Well, how many 5s do we have now, all being multiplied by each other? 7 of them. It's 5 to the 7th. So what we have right here is just basically what's going to become the product rule. Right? If I have 3 5s times 4 5s, well, now I have 7 5s. Okay? And this is what our problem wants us to do. And when we have really big numbers like this, I'm okay with you leaving your answer as 5 to the 7th. I'm not going to be very picky on that. We'll talk more about that later, probably. All right, so that does bring us to the official product rule for exponents. So as long as everything's behaving well, notice that the bases, these are both a's, the bases of the exponentials have to be the same. So in our example, we had 5s. Then if the bases are the same, you just add the exponents. Okay, the bases have to be the same. It's making that comment right here. Be careful. So let's do example 6.2 together. So if you do example 6.2, we'll start by 7 squared times 7 to the 10th. The bases are the same. Very important to notice. You don't have to write this, but you should notice it. The bases are the same, so we just add the exponents together. Well, 2 plus 10, that's 12. And this is a very, very, very big number, so we'll just leave our answer like this. Okay? Let's do another one, part B. 2x cubed times 4x squared times negative 3x. Now, don't let the parentheses fool you here. These parentheses are honestly useless. These parentheses have no point, no purpose in life. Oh dear, it's getting existential. We don't need them. Okay, so if you wanted to, right, sometimes we do need parentheses. For adding things together, subtracting things, that's a very common time to need parentheses. But multiplication is associative, it's commutative. There's a lot of fancy words to talk about multiplication. But these are all being multiplied by each other. This is the exact same thing as 2 times x cubed times 4 times x squared times negative 3 times x. These mean exactly the same thing because of how multiplication works. Everything's getting multiplied, and we can multiply it any order. So I'm not going to write this next step very frequently, but I'll write it once. So we can multiply all the numbers together. So we can have the numbers 2, 4, and negative 3. We can just write them all at the front and multiply them together. And then we can multiply the x's all together. x cubed times x squared times x. Well, 2 times 4 times negative 3 should be negative 24. Sometimes I underline things to show that I've dealt with them. So if you're wondering why I'm underlining this, because they became the negative 24, I only have to worry about the things that aren't underlined anymore. Well, now we just add the exponents because they all have the same base. This has an exponent of 3, exponent of 2. Does this have no exponent? Remember that this secretly has an exponent of 1, not 0. So when we add those together, it'll be 3 plus 2 plus 1 is 6. We get negative 24x to the 6 is our answer here. All right, try to pause the video and do letter C on your own, okay? Pause me now. Don't let me say another word. If you hear the next word I say, I'll fail you all. No, that's not true. That was a joke. Hopefully you've paused the video and we're just going to go through the answer. So we're going to do this just like we did before. So it's all multiplied together. So we can multiply them in any order. If you want, you can follow the same steps that we did last time, but we're going to go a little faster here. Let's multiply the numbers together. 5 times 2 is 10. Let's multiply the a's together. A cubed times a to the 9th. Add the exponents because they have the same base. A to the 12th. B to the 7th. B squared. Same base. Add the exponents. And the only thing left is a c to the 4th. It's all alone. That's our final answer. So you can do this in a lot of steps. You can do this in a couple steps. Find the balance that works for you. So the quotient rule is next, and it's very, very similar. Okay? You can follow this rule. That sentence is not working for me. Let's look at example 6.3, okay? Because it's very similar. If we do that, we have 4 to the 6th divided by 4 cubed, and let's expand it out just like we did in the first example of today. 1, 2, 3, 4, 5, 6 fours being multiplied. That's the definition of 4 to the 6th. And on the bottom, we have 1, 2, 3 fours multiplied by each other. Well, if I have everything factored in a fraction, I can cancel the factors. I can cancel the common factors. Well, what's left? The bottom is canceled. There's only a 1 left over. The top is just 4 cubed. So if they're being multiplied, we add the exponents. If they're being divided, we subtract the exponents. And that is our quotient rule. Or it should be. Let's see if I'm right. So blah, blah, blah. If everything's working great and you have 2 exponentials with the same base, the a's have to be the same. The bottoms have to be the same. Then you can subtract those exponents. Top minus the bottom. All right. Be very careful which way you subtract it. Let's do last example and then we'll be done with this video. So example 6.4 says simplify this stuff. We got x to the 7th over x to the 4th. They have the same base. We should just be able to take the top exponent, subtract the bottom exponent. 7 minus 4 should be 3, if my calculations are correct. Some of you have noticed that sometimes they are not correct. Thank you for pointing out those errors. If you're looking at the homework and saying, Jason, where the heck did you get 17 from? And I say, that's a good question. And then I say, oh, that's an error. Don't hesitate to let me know if you think there might be an error in the video or in the homework. All right, part B, a to the 7th, b squared over a cubed times b. So we'll do this kind of in 2 stages. Look at the a's first. The a's have the same base. 7 minus 3 is 4. Look at the b's. 2 minus, remember there's a hidden 1. Anything that doesn't have an explicit exponent is to the first power. So b is 2 minus 1. 2 minus 1 is 1. Well, We'll write that as a to the fourth, just times b. We don't need to write that one. And the last problem, we'll have 8 over 6. Whoa, I'm getting ahead of myself. 8m to the 7th, n to the 4th, divided by m to the 5th times n. We'll do the same thing. We'll do it. Everything's multiplied together is why we can do this. Because everything's multiplied together, we just look at the numbers. So maybe off to the side, we'll go, what is 8 divided by 6? Well, we can divide the top by 2 and the bottom by 2. 8 over 2 is 4. 6 over 2 is 3. And say, okay, 8 over 6 simplifies to 4/3. For the m's, they have the same base. Subtract those exponents. 7 minus 5 is 2. And when we subtract the exponents, the result is always on the top. Here there wasn't a top, but there kind of is still a top in this one too, right? We can think of this as a to the fourth, b to the first power divided by 1. But now there's definitely a bottom, definitely a denominator. N to the fourth divided by n to the first is going to be, subtract those exponents, n cubed. And this is our final answer. And that's the quotient rule. Go ahead and get started on the homework. Let me know if you have questions. It's a long one this week, but not as long as it could be. I don't know, I sound like... Anyway, get to work.